Welcome to another session of Inf154. So for this session, we are going to do arrays. So what's the motivation behind arrays? So let's say we want to write a code that receives three numbers from three numeric up-downs, and we want to calculate the sum and display the result in a message box. So when we do our IPO models, we have to identify the inputs, then the process, then the output. So in this case, we are just calculating the sum of three integers. So we need three variables for that. Then to calculate the sum, you all know how to calculate the sum. We just say sum equals to a plus b plus c. Then we output the sum. So after this IPO, we go to the form design. This is what we did. Like this is the basics. So for the form design, we have this form which have three labels A, B, C, and three numeric up downs to receive those numbers. Then we have the rich text box, which is not necessary. Then we have the submit button. Then, so the code now. So in this submit button event handler method, we are going to declare three variables. So int A, B, and C. So how are variables represented? Remember, a variable is a memory location. So this A will be a memory location which is stored in like some address. So you guys don't care much about addresses since you are doing a high level language. If you are doing a low level language like assembly, there you deal with memory all the way. So you guys don't care that much about the memory. So at the specific address, then you declare B. B is stored in its own memory location at the different address. So these addresses are not consecutive. They are just different memory addresses. Then you have C, which is stored in a different memory location, and that memory location it has a different address. So again, to get these inputs from the user, you just say a equals to convert to int32 nuda.value. You all know that this by now. Then you just say sum equals to a plus b plus c. So the sum will store, like when you say a equals to whatever, it's going to take this value. In this case, it's 10 and store it in a. B equals to, it's going to store this value in B, and C equals to, it's going to store this value in C. So when you say sum equals to A plus B plus C, it's going to add 10 with 20 with 30, then 60, then you can display the result in the message box. So this seems to work fine, but what if you had like a million items or even 1,000? Like you don't want to write 1,000 variables. This means you're going to have maybe A, B, C, D, E, F, G up to Z, but those are 26 variables. Then maybe A1, A2, A3, A4, so that will be a lot of work. So again, remember a variable is a what? It's a memory location. So here it's a typo, it's a memory location. It's a single memory location that stores values. So how can we fix that issue? What if we really want million items? That's why we have the arrays. So an array, it's a group. You can say it's a group. You can say it's a list. You can say it's a sequence. It's a sequence of what? It's a sequence of contiguous memory locations. So the keyword is that is contiguous memory location, or in simple terms, you can say continuous memory locations that have the same data type. So the important thing is that continuous memory locations, then same data type. So how do we declare arrays? So to declare an array, you just need the data type. Then you need these square brackets to indicate that is an array. Then you need the name. Then you say array name equals to new. Then you put the data type. Then you put the square brackets. Inside the square brackets, you're going to put the size of your array. Or alternatively, you can do everything on one line. You just put the data type, square brackets, name of the array equals to new, then data type, then you put the size of the array. So let's see the meaning of these things of this syntax. So data type refers to the type of data that the array holds, or you can say the data type of the elements or the data type of the memory locations. So this can be an integer. This data type can be int. Within data types, it can be a string, it can be a double, it can be anything, a character. Then array name refers to the name of the array, so it can be anything. The way you are naming variables, that's how you will name arrays. So at the end, an array is a variable that stores a group of elements. Then we have the size. We saw that when we are declaring an array, we put the size variable. So what's the size variable? So the size is the number of elements in the array. So when we are referring to the size, you always start from 1. When you are referring to dot count, when you are referring to dot length, like when you are referring to size, you always start counting from 1. Don't make a mistake of counting from 0 when you are referring to the size. Then when you are referring to the position, when you are referring to the index, that's where you start at 0. But the size always start at 1. So normally I just say, how many fingers do you have on one hand, 4 or 5? So you must say 5 fingers. You can't say I have 4 fingers. So that's the idea of size. So always ask yourself this question when you are counting the number of elements in an array or in a list box, whatever. But this is an interesting way of remembering how the size works. So examples. So an example, we have this int. Then this int is an array. So this is it's an array. We put the square brackets, then we put the name of the array. So we say a equals to new int, then we put the size, which is 4. Notice that this is int, this is int. So the data type has to be the same. Or alternatively, you can do this in one line. Int square brackets, the name of the array equals to new. This new is always there. Then int, then you put the size. So this creates, so this line only, int it creates an array that has nothing. So it doesn't have anything. Then when you say a equals to new int, then you put the size. So it's going to create how many memory locations? 4 continuous memory locations. So by default, integers are initialized to 0. So by default, these are initialized to 0. So you are going to create 4 memory locations in memory like this, where you can store values of the same type. This is an array of integers. So that's why we have int, because this is an array of integers. Then when referring to the position, we will get to the index soon. When referring to the position, you start at 1, at 0. So you always start at 0. You are referring to the position. Then you say 1, 2, 3. So notice that the maximum position that you can access is the size of the array minus 1. But we'll get to this in detail. But now we are just explaining how this works. So the data type must be the same as I mentioned. So this is an array of integers. By default, the elements are initialized to 0. So this is a group of elements. This is a group of memory locations that can store values. So in this case, we are storing 4 values because the size was 4. Then another example, string array. So when you say string array, again, this array initially it's pointing to null. Then when you say equals to new string, it's going to create memory location, new memory locations of type string. And the size of those memory locations is what? It's 3. So it's going to create an array of size 3. So these are memory locations which can store strings. So in this case, you have 3 memory locations. So you just say 0, 1, then 2, Then, but we will get to this positioning. Then an alternative will be string, just do everything on one line actually. So you see, this is a small letter s, so this is just my handwriting. So this is a small letter s, just be careful, it's not a capital letter S, it's small letter s. So this will create an array of strings, or it will create memory locations. How many memory locations? 3 memory locations that can store what? That can store strings. Then you can continue this double. By default, strings are initialized to empty strings. Then double, then square brackets, whatever, b equals to new double. Again, 5, it's going to create new 5 memory locations that can store double values. So this is an array of what? Of doubles. Then now we are going to the most important property. So the array index. What do we mean when we say the index of an element in an array? So the index of an element refers to the position of an element in an array. So when you are referring to the index, you always start where? You always start at 0. So the last index accessible is size -1. We saw that, and you will see that in detail. For example, then now we are going to populating an array. So populating an array. So before you can populate an array, you have to create one. So in this case, we are creating an array of integers. So we have an array of 3 integers because size is 3. So 3 memory locations which can store integers. Then positioning or the index, we always start at 0. Then we say 1. Then we say 2. Like that. So the syntax for populating or adding values to the array, you just say the array name, then you put the square brackets, then you put the index, then you put the value. So the index must be a valid index. So in this case, we can only access 0, 1, 2. We cannot access 3 because it's not within the range of this specific array. So for example, if we say array 1 equals to 10, it's going to go to the array and it's going to go to position what? 1. Then it's going to store what? It's going to store 10. That's why we have 10 here at position 1. Array I refers to one element, hence the data type. Since the data type of an array, it's int square brackets. The data type of one element in the array, it will be int without the square brackets. On my left, I have an integer. On my right, I have an integer. So this is a valid assignment. So it's going to store 10. Then if I say array at position 2, this means array at position 2. So I'm going to go to 0, 1, 2. So in this memory location, I'm going to store what? I'm going to store this 20. So I have this 20. Then if I say array at 0 equals to 5, it's going to go to position 0 and store this 5 in the memory location. So at the end, my array is populated. If I say array at 1, so now I'm referring to this. This is the latest update of the array. So when I say array of 1 or whatever is at position 1, plus equals to 5. So we know that this is the same as what? As array 1 from the basics. We know that this is the same as array 1 equals to, then we transpose this array 1 here. So this was lecture 3 somewhere there. Then plus 5. So what is array 1? Array 1 is 10. So we have this 10. 10 plus 5 is what? It's 15, and it's going to be stored where? At array 1. So that's why we have 15 here, because of this expression. So when we are referring to array 1, we are saying here 10. Then 10 plus equals to 5 is what? It's 15. Then we are storing it back where? To array 1. So that's the meaning of that. So that's how we can change values or manipulate values. Then how do we access elements? Accessing means we are reading from the array. So when you are reading a book, you are not changing anything because you are reading. Then when we say populating or change values, we are writing to the array. So writing, when you are writing on paper, you are changing. Like you see here, it's blank. When I'm writing, I'm changing something. So that's accessing and changing elements. So accessing, we are just reading. When you read a book, the book won't change just because you are reading the book. No, it won't change. You are just reading the book. Same as accessing elements in an array. So to access an element in an array, you just say array name, then you put the specific index. Then as an example, let's say you have an array containing the following values. So we say int sum equals to array at 0. We are accessing the element at position 0. We are not changing it. So 10 plus, we are accessing the element at position 1. So at position 1, we have 20. So we have 20 plus array at 2, element at position 2, which is 30. Now the result will be what? Will be 60. So sum will store what? It's going to store 60. So that's how we access. Even here, let's say you have an array of strings with size 2, or it has 2 elements. So I say rtx.text plus equals to, let's say, name plus a of 0. So it's going to say the name, then plus a of 0 is going to return what? This a. So we are going to concatenate this name with this a. So this is accessing. It's not changing. We are just getting values. We are just reading values from the array. So that's the idea of accessing. Then array initialization. So another important property is the initialization of your arrays. So sometimes we know the values of an array in advance. So for example, let's say they ask you to create an array containing the following values. So you have 5, you have 10, you have 15, then you have 20, then you have 25. So these are integers. This means the data type has to be what? It has to be an array of integers. Then I gave that array a name. Since they were not specific, you can name it anything. Then you say equals to, when you know the values, you just put these curly brackets. Then you put the values separated by what? By commas. So I'm going to put this 5 separated by a comma, put the 10 separate by a comma, put the 15 separate by a comma, 20 separate by a comma, 25 separate by a comma. So in memory, you are going to have these memory locations that stores these values: 5, 10, 15, 20, 25. These comma separated values, they are going to be stored in this specific array. Then at position 0, again, when you are referring to the index, you start at 0, then 1, then 2, then 3, then 4. But when you are referring to the size, we have how many elements? 1, 2, 3, 4, 5 elements. So don't confuse the position and the size of the array. Then another example, create an array with the following values. So you have true, false, true. So these are Boolean values. So the data type has to be an array of Boolean values. Then you put the name of the array, then you say equals to. Since we know the values, there's no need for us to use the new thing. We can just put these curly braces, then we put the values true, then we separate true, then false. I mean, here it was true. This was just a mistake, but that's the idea. Then another example, store the following names in an array called names. So these are strings. So names are strings. So we have to have an array of what? Of strings. Again, this is a small letter. It must not be a capital letter, this S. So names equals to, since we know the values, we just open the curly braces, then we write John, Linda, whatever, but these are strings, so we have to put double quotation marks. So it's going to create an array called names. Then this array stores like this John, Linda, Rose on different memory location. Then again, you start counting from 0, then you go from 1, then you go to 2 actually. Then how do we get the first element from an array? To get the first element in an array, you just say array name, then you say 0. So this means the first element is always at position 0, since we are always starting at 0. So for example, if you have this array which stores 10, 20, 30, then when we say a of 0, we are referring to the first element, which is 10. So the first element is 10. Notice that 0 is the index of the first element. It's not the first element. 0 refers to the position. So the first element, what is stored in that position 0? It's your first element. Then now we can go to the size of the array. So when it comes to the size of the array, the size refers to the number of elements in the array. Again, you start counting from 1 when you are referring to the number of elements. For example, how do we get it? In general, you just see array name.length. So array.length will return the number of elements in the array, and it's always an integer. Even the index is always an integer. When we are referring to the index, you cannot put a double because it's always 0, 1, 2 up to the size of the array. So here array name.length returns the size. For example, int n equals to a.length. In my left, I have an integer. A.length will return the number of elements. So in this case, we have 1, 2, 3, 4. So we have 4 elements. So n must store 4. So this was a typo. So this must store 4 at the end. So how do we get the last item in an array? To get the last item in an array, you just say array name. Then you say rname.length minus 1. Remember, rname.length returns the number of items. The maximum position that you can access is the number of items minus 1. So in this case, you see we have 1, 2, 3, 4 items. When we say, for example, last equals to a of, then we say a.length. A.length is what? 1, 2, 3, 4. It's going to be 4, then minus 1. This is the last element. So it doesn't matter with the size. You see, at the end, it's going to say a of 3, which is 40. So it doesn't matter. The size doesn't affect. For this one, for example, if we say a.length, we are going to get 1, 2, 3. So 3 minus 1 is what? It's 2. So it's going to refer to the index of the last element. To get that last element, we just say a of what? A of 2. So that's how we get the last item in an array. So you have to know this. Then now we can move. Then how do we loop through an array? Looping through an array is straightforward. You just start at 0. Then as long as you didn't reach the end, do something with the current element, then I++. So you always start at 0. Then you say I less than array.length, then I++. Remember, the maximum item that we can access is r.length minus 1. That's why we are saying less than here, not less or equals to. You cannot say less or equals to, because let's say a of a.length, it's not defined. Remember, that's because we are starting at 0. So you just start at 0. Always, this will always be the same. Like, it won't change unless if you are trying to loop through the array in reverse. Yeah, it can change, but this is the code. Always the only thing that can change is k. You can use k here, then you can use k here, then the name of the array can change. But other than that, it's the same thing. You start at 0. As long as you didn't reach the end, you do something with the current element. And how do we reference the current element? You just say array of I. If this was k, you're going to say array of k. So that's how we refer to the position, or how we refer to the current element. So this means I equals to 0. Start at 0 until the last element, I less than array dot length. Then move one position forward. I plus plus means move one position forward. Then, or you can use a while loop. Your initialization goes outside. Then while I is less than array dot length means as long as you didn't reach the end, then do something with the current element. How do we get the current element? We are just saying array of I. Then we say I plus plus. Then now we can get to examples just to understand these arrays. So typical array problems. So given an array numbers, so the name of the array was specified. So that stores like decimals. Write a code to calculate the sum and average. So to solve array problems, if they didn't give you an array, you have to assume a small array with values like random values. For example, for me, I assumed that numbers will be of this size. So I can see numbers is this array having 3 elements. Start at 0, 1, 2, then you have 10.1, 20, and 30. Then you can do the pseudocode, or you can do it in your head. It's not necessary. So when you do it manually, you start with sum, which is initially 0 because you didn't calculate the sum. Then the average, which is also initially 0 because you didn't calculate the average. Then what do? You iterate through the array. So how you iterate through the array starting at 0 to the end. So you iterate through the array starting 0 to end. So you start here, then you move here, then you move here. That's iterating through the array. Then what do? So for every iteration, add the current element to the sum. So if you are here, you are going to go here, add this to the sum. Next iteration, you move forward, add this current item to the sum, move forward, add this current element to the sum. So now we can convert this. After that, after calculating the sum, you calculate the average. So the average is the sum divided by the number of elements. So how do we do that? Now with the code. So we have to declare double sum equals to 0, average equals to 0. Then how do we iterate through an array? So we did that previously. You can either use a for loop or a while loop. But for me, I'm going to use a for loop. In most cases, we use a for loop unless they specified. So you are going to start at 0 until you reach the end. Then this means move forward. I plus plus in arrays, it means move one position ahead. So sum plus equals to numbers I. So for every iteration, you are adding the current element to the sum. That's the meaning. Then average equals to the sum divided by the number of elements. How do we get the number of elements? You just say the array name dot length. In this case, we are dealing with numbers. Then you just say numbers dot length. That's how you calculate the average. Then after that, as an exercise, you can write the code that will display the results. Then you have to show the execution of this code for this specific array. So we want to know the sum and the average for this specific array. So if you want to see how execution works, you can refer to the for loop video, which is video. I'm not sure, but it's written like INF on the YouTube playlist. It's written for loop. You will see how we execute like with the list box. It's similar to this array. So you can do that as an exercise. And then now we can move to another question. Given an array of rainfalls, write a code to calculate the minimum rainfall. Or let me just show an example of how this works actually, of how this code works. So let's say you have this double array, for example. For me, I'm going to just, for simplicity, I'm just going to do this, where you have these numbers. Then I want to calculate the sum, the average and the sum. So I'm going to say double sum equals to 0, then average equals to 0, like that. Then I'm going to look through the array starting from 1. I must be less than what? Must be less than r dot length. So it must be less than the size of the array. Then we just say sum plus equals to a of I. Then how do we execute this? Then average equals to sum over r dot length, like something like that. So when you start, initially your sum is 0, average is 0, then I is what? Is 0. So I will start at 0. Then we check, is 0 less than array dot length? In this case, how many items do we have? 1, 2, 3, 4, 5. So we have 5 elements. So 5, yes. So this is true. So what are we going to do? We are going to add the previous, to the previous sum, we are going to add array at I. So in this case, our previous sum was 0 plus array at I is what? Array at 0. So at position 0, we have 10. So this is 0 plus 10, which is what? Which is 10. So now we are going to increment. Now we are done with this line of code. So we are going to increment I. So I will be what? 1. This means move forward. Then we have to check, after incrementing, we have to check, is 1 less than 5? So it's this 1 less than 5. Yes, 1 is less than 5. What are we going to do? We are going to execute the code inside the loop. The code inside the loop says sum plus equals to, so the previous sum is 10 plus array at what? At I. So I is 1. So it's going to be 10 plus what? Plus 10. Oh, at 1 we have 20, not 10, so which is 30. After that, where do we go? We increment our I. So I will be what? Will be 2. So we check, is 2 less than 5? Yes, 2 is less than 5. So sum equals to the previous sum, which is 30, plus array at what? At position 2, which is equals to what? So 30 plus array at position 2, we have 30. So 30 plus 30 is what? Is equals to 60. Then I will be incremented to what? To 3. Then we check, is 3 less than 5? Yes, 3 is less than 5. So sum is equals to 60 plus what? Plus array at what? At 3, which is equals to what? 60 plus at position 3. So it's 0, 1, 2, 3. So at position 3 we have 40. So we have what? We have 100. Now I will go to what? To 4 according to this I++. So we have to check, is 4 less than 5? Yes, 4 is less than 5. Sum is equals to what? Is equals to the previous sum, which is 100 plus array at what? At 4. So 100 plus array at 4. At 4 we have what? We have this 50. So 50, which is equals to 150. Now my I is equals to what? 5. Then we have to check, is 5 less than 5? Yes, 5. I mean, no. So we exit the loop. Then where do we go? We are going to calculate the average. So the average is going to be the sum. So the latest sum was 150. So it's going to be 150 divided by what? By the number of elements in the array. So array.length. So here we have 1, 2, 3, 4, 5. 5 elements, which is equals to 30. So our average will be 30. Our sum will be 150. So that's how you execute that specific loop. So I hope that makes sense. Now we can move to the next code. So given an array of rainfalls, write the code to calculate the minimum rainfall. So rainfalls, we have this specific array. So how can we solve this? So the pseudocode or the algorithm, if you are doing it manually, you are going to assume that the first element is the mean. So it's the minimum. You assume this is your minimum. Then after assuming that, you iterate through the array starting at 1. Why do we start at 1 now? Because we already processed the first element as our minimum. Then we compare the current element. If the current element is less than our minimum, then the minimum will be what? The current element. That's how we do it. So in this case, we are going to assume that 10.5 is our minimum. So we have to iterate starting from here to go here. We have to compare. It's 20 points. I mean, it's 20.6 less than our minimum, which is 10.5. No. So we don't update. We go to the next one. We check, it's 5 less than the minimum, which is 10.5. Yes, now our minimum will be what? Will be 5. Then we go to the next item. We check, is 81 less than the minimum? No. So we don't do anything. Then we reach the end of the array. So at the end, our minimum will be what? It will be 5. So now when you convert this to code, we have this double minimum equals to rainfalls at position 1, at position 0. That's how we get the first element. So we assume that the first element is the minimum. Then how do we iterate through the array? We starting from 1. So we say I equals to 1, I less than rainfalls dot length, then I plus plus. So if rainfalls at I is greater than the mean, so our minimum will be what? Rainfalls at I, like that. So this means if the current element, oh, here I made a mistake, it's less than. So this is less than, not greater than. You do greater than for max. So for max, you just name this max, then here you say greater than. Here it must be less than. So this is a mistake. So if rainfalls at I, if the current rainfall is less than mean, then our mean equals to rainfalls at I. So again, let me show the execution just in case, not to leave you guys hanging. So we are going to have, let's say, double rainfalls is equals to, actually this is an array, so I need the square brackets. Rainfalls, so it's rainfalls is equals to, let's say 10, then 20.6, then we have 5, we have 81, like that. Then I'm going to say, okay, I'm going to assume that the first element is the mean. So double minimum equals to rainfalls. Then I'm going to say that's how we get the first element. Then I'm going to iterate through. I equals to 0. I must be less than rainfalls dot length. Then I plus plus. Then I'm just going to say if the current rainfall, so rainfalls at I it's less than the minimum. So this means we have to update the minimum to be what? The current rainfall. So let's see how it works. So initially, I have this minimum which is equals to rainfalls at 0. At 0, I have 10.5. So my rainfalls will be 10.5. Then I is equals to 0. Now I'm executing the loop. I equals to 0. So I have to check, is 0 less than rainfalls.length? Rainfalls.length, how many items do we have? 1, 2, 3, 4. So we have 4 items. So is 0 less than 4? Yes, 0 is less than 4. We have to execute the code inside. Then we have to check the current rainfall. Actually, here I was supposed to start at 1. You see, even me, I make mistakes. So here I was supposed to start at 1. So I have to compare. It's 1 less than 4. Because we already processed 0, it doesn't make sense to start executing at 0. 0 is less than 4 years. I have to compare the current element. So I have to check A of 1. Is it greater than the minimum? So A of 1 is what? At position 1 we have 20.6. So and here it's less than. So here we have less than. So is 20.6 less than the minimum? What's the minimum? 10.5. No, so I don't update the minimum. So I'm done with the if statement. Then I go and increment what? I. So my I will be what? Will be 2. Then I'm going to check, is 2 less than the size 4? Yes, now we are checking the loop condition. So yes, that's the case. What are we going to do? We are going to execute the inner loop. So I have to check, is rainfalls at I? So here I said A or R just for simplicity, or let me just type it anyways. So this is rainfalls at I. So rainfalls at I is what? Now I is 2. Then we check, is it less than the minimum? We check the condition under the if statement. So rainfalls at 2, we have 5. So it's 5 less than the minimum. What's the minimum? 10.5. Yes, what are we going to do? We are going to update the minimum to be what? Rainfalls 2, which is that 5. So 5 will become our minimum. Then after that, I'm done with the if statement. I increment. So I now will be what? Will be 3. Then I have to check the loop condition. Is 3 less than the size of the array? Yes, 3 is less than the size. So we are going to execute the code inside. Then the code inside, we are going to check if rain falls. So we are going to check rain falls at 3. Is it less than the minimum? So rain falls at 3, we have 81. Is it less than the minimum, which is 5? No, so we don't update. We just go to I equals to 4. Then we check, is 4 less than 4? No, then we exit the loop. So at the end, the latest update of the minimum was 5. So the minimum will remain 5, which is true. Here 5 is the minimum element. So that was the execution. Then we have to, this is an exercise, so you can read through that. Given an array, so this is your own exercise, it's not mine. Write a code that will swap the mean and the max. Then swap the middle element with the mean. For example, given this array, we know that from this array, I can see that the minimum is 5. Like manually, I can see that the minimum is 5, maximum is 81. So I have to swap these two. Then after swapping these two, 81 must go here, then 5 must go here. Then after this, I'm going to look for the middle element, which is calculated by array length over 2. So I have 7 over 2, which is array of 2. The reason we ignored 2.5 is because this is integer division. So it's just going, we are going to ignore the decimal. So array of 2 is what? It's 8. So I'm going to swap this 8 with what? With the minimum. So 5 will be swapped with 8 like that. So the final array will be this. So notice that this array won't be like this. So don't hard code values. You have to code for all possible arrays. So that's an exercise. Then now what happened? I think there's a page missing. Something is so wrong with this document. There's a page missing. Okay, let me check my book real quick. So the order, because I have the backup on my book, because this PDF, it seems as if it doesn't go in order. So now we want to go to applications of arrays. Oh, not necessarily applications yet. So this is the other page. So given n, write a program that creates an array of size n and populates the array with random numbers between 0 and 100. So we want to create an array of size n, then populate that array with random numbers from 0 to 100. So again, the solution, I'm going to do my pseudocode, which is not a must. So the pseudocode, I'm going to create an array of size n, which is easy enough. Then after creating the array, I iterate through the array starting where? At 0. Then for every iteration, I generate a random number from 0 to 100 and store it inside the array. As easy as that. So there's nothing much to this one. So here is the array creation. So I create an array of size n, and it's of what? Of integers. Then after that, to generate random numbers, I need a random number generator. That's why I have this. Then I loop through an array starting from 0, then I go up to the end, I plus plus. So array of I is equals to r dot next. So this will generate a random number from 0 to what? To 100. So this will generate a random number from 0 to 100, and it will store that to what? To your array, like that. So let me see which one follows actually, because now my thing is so messed up. The document is messed up, but the book is in order. So now we are going to move to applications of arrays. So let's consider applications of arrays. Hopefully the pages are all here, because if they are not all here, yeah, it's gonna be messed up. Let me just confirm if the page is there for applications of arrays. Yeah, it's there. So applications of arrays, where do we apply arrays? So list boxes, we did the list box many times. You can refer back to the videos of the loops on the YouTube channel. So we know how a list box works. A list box is a control used to store an array or a list of items. So how do we add items to a list box? You just put the name of the list box dot items dot add, and then you just say value. Then refer to 14 and 15, like video 14 to 15 on the YouTube playlist for detailed explanation of the list box. Like we did examples, even minimum, maximum, sum, like we did everything with the list box. Generating random numbers to a list box, we did that. So the other important property of a list box is the size of the list box. It's because it's an array, we can get a size. So in this case, we use dot count. We don't use dot length. Dot length doesn't work on the list box, unfortunately. So example, let's say lst.items.add 10. So it's going to add 10 at the first available space. Lst whatever dot items dot add 20 is going to add 20. Lst dot items dot add is going to add this 30. Lst dot items dot add is going to add 40. So I'm just running through this because we did this in detail on those loops videos. So refer to them if you want to understand the list box in detail. Then how do we access elements? Accessing, it's reading from the list box. So we just say the name of the list box dot items. Then you put the index because a list box is a control that stores an array of what? Of items. Notice it's not necessarily an array of strings, array of integers, array of doubles, an array of items. So when you access, always convert to, for example, int n equals to convert to int32, then lst.items at 2. So it's going to go to the list box, then it's going to go to position 2. So we have 30. 30 converted to int, it's going to be stored in this n. So that's how you access. You just, like the way we did with arrays, now it must be familiar. Like we already did it without arrays before. Then again, you can use that in an if statement. So let's say you have an integer I which is 0. Then if convert to int32 lst.items at index I is 0. So now is it greater than 0? If it's greater than 0, maybe message box.show the number is positive, like you can do that. But the idea is that when you're accessing from a list box, you always convert to something. It can be convert to string, convert to int32, convert to double. It doesn't matter, you have to convert. Then now let me consider which one is the next page, because here now everything is messed up. So the case one thing, let's see which one is that one. So arrays and list boxes. So problems. Case one. So given a list box, we can create an array using a list box. So that's the idea. You have to know this. So example, given the following list box, create an array called names and store the elements from the list box to the array. So example, this is your list box which contains these names. We want to store these in an array. So the solution, pseudocode, you create an array having the same size as the list box because you want to create an array, you want to sort of convert this list box to sort of an array. So this array must be of the same size as the list box. So here you are going to have position 0, 1, 2, 3. Even your array must be 0, 1, 2, 3. So the array must be of the same size as the list box. Then you just transfer the elements. This John will be transferred to this. This Susan will be transferred to that. This Loazi will be transferred to that. And this Musa will be transferred to that. So that's the idea. Iterate through the array or list box. It doesn't matter since they have the same size. Starting from 0 to the end, for every iteration, populate the current element of the array with the current element in the list box. Then as an example, let's say string names equals to new. So for this one, it's lstn, so we are going to create an array having the same size as the list box. So string names refers to an array of strings. Then equals to new string. Then how do we get the size of the list box? lst.items.count. So whatever name.items.count, this will return the size of the list box. In this case, we have 1, 2, 3, 4. So this is going to create an array of what? Of 4 items like this: 0, 1, 2, 3, 4 items. Then you just iterate through the list box or the array. It doesn't matter since they have the same size. So start at 0 until the end, then move forward. Then you take the current name. So you want to store something in the current location of the array. So you have to take whatever is that, you have to take the current element in the list box, but you have to convert it to what? To a string, because this is a string, this is an item, so they are not matching. That's why we are saying to string. So that's the general idea. Then you can execute this manually, I guess. Let me see if I did it manually. Yeah, I did manually actually. So let's analyze it. So analysis, let's assume that the list box has this. So in Visual Studio, it's represented like this, but every time we see a list box, we have to think of the array dot items. So we have dot item set 0 refers to this, dot item set 1 refers to this, dot item set 2, dot item set 3, like that. So the first line of code, that one, string names equals to new, we know that is going to create this array of strings having 4 elements. So this is the array of strings having 4 elements, because the size of the list box is what? It's 4. You have 1, 2, 3, 4. So you are going to have an array of 4 elements. Then you are going to start where, when you're executing your loop, now you can execute your loop. So I equals to 0, then you check if that is less than the number of items in the array. So I equals to 0, then we check, is 0 less than 4? Because we have 4 items. Yes, 0 is less than 4. What are we going to do? We are going to say names at I. So names at I equals to whatever is at position I in the list box. So in this case, at position 0 in the list box, so this is 0, 1, 2, 3, or it's here actually. At position 0, we have John. So at position 0 for the array, we are going to start, we are going to start John. So this John is going to be transferred to this. Then after that, we increase our I will be 1. We check, is 1 less than 4? Therefore, names at 1 will contain what? This Susan. So it's going to take this Susan and put it at position 1. Again, it's just going to continue. I equals to 2 is 2 less equal 2 less than 4 years. Just put the Loazi at position 3. Then I equals to 3, then you go to position 3, you get this Musa, then you just put it at position 3, like that. Then I equals to 4 is 4 less than 4. Yes, I mean no. So you have to exit the loop. So that's very basic. Like it's not that challenging. I'm sure you can process this. Now we can go to case 2. So let me see the case 2. Where's the case 2? Since these things, they are just messed up. So I'm looking for case 2. Yeah. So given an array, we can add items of the array to the list box. So this is the other way around. So let's say you have an array, we want to add these elements of the array to a list box. So the pseudocode is straightforward. You iterate through the array starting at 0 until the end. Then for every iteration I, you add the current element of the array to the list box. So when we convert this to code, we have for I equals to 0, I less than numbers dot length I plus plus lst n.items.add, we know that the number set I. So we are adding the current element. So initially we are going to start with an empty list box, then we have this array numbers. So let's see the analysis. So when we start I equals to 0, then we check is 0 less than the number of items. So number of items is 1, 2, 3, 4, 5. So is 0 less than 5? Yes, 0 is less than 5. So it says array 0. Array 0 refers to 5 to the list box. So this will be added. Then you just continue the process. You move to position 1. Is 1 less than 5? Yes. Add whatever is at position 1 to the list box. So 10 will be added. Then you continue the process until you reach the end. I don't think it's necessary for me to just go step by step because it's just straightforward. You just keep iterating through the array. You move from this, add to the list box, move here, add to the list box, move here, add to the list box, move here, then add to the list box. Then why can't we just say lst.items equals to array? If we consider the data types, so for the list box dot items, it's an array, but it's an array of what? It's an array of items. Then on the right, we have an array of what? Of integers. So these, they don't match, even though both are arrays, but they are not matching here. So they are not matching. We cannot do this. So the data types don't match. Unfortunately, there's no convert for arrays. You cannot say convert to items, convert to int32, whatever. It won't work. So you have to use a loop if you want to do it. Then let me see if I'm in the correct direction. So now we are going to consider the rich text box as an array. So a rich text box is an array of lines. So we know that in Visual Studio it's like this, but behind the scene it's just an array of lines. Like where you have dot lines 0 refers to the first line, dot lines 1 refers to the second line, dot lines 2 refers to this, and so on. So lines, they are strings. So every line is just a string or is just a text. Even if you put numbers in the list box, they are going to be considered as lines, as strings. So the data types of rtx.lines, or the name of the rich text box.lines, it's a string array. It's an array of strings. So it's valid. Therefore, since it's an array of string, it's valid to say maybe string names equals to rtx dot lines. Dot lines is an array. Then names is an array of strings. Even dot lines is an array of strings. So if we do that, this will be converted to an array of what? Of strings, like this. So this line is valid because you have a string array, then you have a string array again. Now let me see if I'm going in the right direction. So let's say we have this rich text box. Then can we say double numbers equals to rtx.lines? Both are arrays, yes, but when we consider the data types, they are not the same. So we cannot do this. And there's no convert to. You cannot do that. So how can we do that? How can we fix this? To fix this, we have to create an array having the same size as what? As the list box. As the rich text box. So to do that, we say numbers equals to new double the name of the rich text box dot lines dot length. Remember, dot lines is an array. So to get the number of elements, we just say dot length. Then to look through the rich text box or through the array, you just start at 0. Then less than, then I plus plus numbers at I equals to convert to int32, then rtx lines at I. So this process is similar to the list box, but here we are using the rich text box. So with the list box, it was what? Lst dot items at I. So it's the same process. So this works the same. So the size of the rich text box, you can say rtx dot length, or you can say rtx dot lines dot length dot lines dot length, or you can say rtx dot lines dot count. But when you use the count, you have to put these brackets. So don't confuse this with the rich text with the list box count. So just be careful. But normally I just prefer to use this length because this count will be confusing. Sometimes you want to put brackets, then it's wrong. So that length is much safer than the count, because now you will confuse the the list box with the rich text box, which is not good. So let me see what's the next thing. Then how can we get an array from a string? So, or a text. So let's say we have string names. So we have this John, Loazi, hello, then they are separated by what? By a comma. Then we want to convert this text or this string to an array. So solution is to identify the delimiter or the character that separate like some part of the text or values or numbers, whatever. In this case, these names are separated by a comma. So this will be the character that separates your names. Then you just say string array equals to names dot split. Then you put like single quotation marks. Then you put the, and in this case I made a mistake. Comma is in this direction. I just made a mistake. So it must be like that. So you use the split. Split, it will split where it says like a comma. It's going to take this and convert it to sort of an array element, this to an array element, then this to an array element. Then it's going to count 0, 1, 2. At the end, you have this array. So that's how the split works. And it only works on strings or on text. So the dot split receives a character or an array of characters and splits a text or a string into an array. So another example, let's say you have a string numbers, then you say equals to, then it's a string. You see they are separated by what? By semicolons. So they are separated by semicolons. So we want to calculate the sum of these numbers. So again, solution, you see that you identify this by commas, identify by you identify the separator, which is the character that separates your numbers. In this case, it's the semicolon. So I know that I can only store this in a string array if I want to convert this to an array, not an integer array. It's not possible. So I have to say string, maybe array equals to numbers. Numbers is a string, so because this is a string, then dot split, then I put the separating character, which is a semicolon in this case. So this will go here and separate these. So this will be taken as an element, element, then this is an element, then 0, 1, 2, 3. Then it's going to be converted to what? To an array, but it's an array of strings. always it converts to an array of strings, not of integers, not of doubles. Then how can we calculate the sum of these elements in the array? We can just look through the array. So when we look through the array, we are going to start at 0 until we reach the end. Then we just I plus plus sum plus equals to convert to int32a of I. So when we take this 10, for example, we are going to convert it to int before we can add it to the sum. Then when we take this 20, it's a string. We convert it to an int before we can add it to the sum. Then when we have this 30, we convert it to int before we can add it to the sum. Then when we have this 40, we convert it to int before we can add it to the sum. Then as an exercise, you can execute this manually. It's not that challenging. Then I think this is the last part. Let me compare. These arrays, they don't want to. Hopefully, this is the last part because I'm tired. 2 videos, one go. Let's see. So, string as an array. So, this one I did it back then. I don't even remember which video was it, but when I introduced variables, I said a string is an array or it's a sequence of characters. I even showed you how to access, how to change characters, how to access characters like it's an array of characters. So let's say you have an array name which stores a string which is name which stores hello. In memory it's represented as an array of what? Of characters, and characters are enclosed within what? Single quotation marks. Like you have single quotation marks, something like that. So it's just single quotation marks. So the size of an array, the size of a string, we just use dot length because it's an array of characters. This is going to count how many characters are there on the array. For example, for this, if we say name dot length, it's going to return how many characters do we have? 1, 2, 3, 4, 5. So it's just 5 characters. So it's just an array of characters. We can change individual characters by referring to the index. The way we were dealing with arrays, like that's how we deal with strings. We can do that. Like we can access individual characters. We can change individual characters. For example, name 0 equals to Z. So Z must be enclosed within single quotation marks because this is a character. This must also be a character. So it's going to go to position 0. So it's going to change this H to what? To a Z. So now we have the 0, whatever. Then accessing characters, again, accessing is reading from the array without changing the elements of the array. So we are going to say name at position 0 if is equals to A. Here we are just determining if the first character is a vowel or not. So we just say 0 equals to A or name 0 equals to E, name 0 equals to I, name 0 equals to O, or name 0 equals to U. Then, yeah, there's nothing much, honestly speaking, than do this. But they work as arrays, but we will consider more when we get to methods. So now I wanted to just consider the other part of the previous practical. So for the previous practical, you had like, let me check. So you had this picture box. So let me just do the thing. So I'm going to say picture box. Oh, it's still initialization. Initializing. So we had this picture box. So I'm going to put it here. For example, then you had what did you have? Let me see. Solution Explorer. Then let me just Right click here, then view properties. So I'm going to store these in ascending order. So I can name this picture box maybe PBX, maybe picture, whatever, or yeah, or die, whatever. It can be anything. Then I'm going to put a button. Then I'm going to say maybe BTN roll. Then I'm going to go to the name of the button. Then I'm gonna change the text to maybe roll. Then I can delete this extra button. Yeah, so we had this picture box, then this, then we had a list box. So I'm just going to put the list box. Then I can name it maybe LBO roles, whatever. So we want to, we are not done actually. Let me just put another thing. We are missing an image list. So I'm going to put an image list here. Where's the image list? Oh, so this is the image list that you had, sort of image list, maybe images, whatever, or pictures, or die, whatever, or dies. Yeah, so you had like a setting like this. So I have to upload images. Let me just go to Google. Then I say dies images. What's happening here? Then images, for example. Then let me go. Ah, dies vector. Then I go here. I'm just gonna take random images actually. So images, let me go to images. Then let me say 126. And see. Yeah, these ones are fine. Download. Continue with Google. Anyways. This thing wants me. Okay, let me just download random images. This will represent our one. So save image as, then downloads. Then I'm going to say one. Then I'm going to, this will represent two. Save image as, then I'm going to say two. Then this will represent three. Save image as, then I'm going to say three. Then I'm going to download this, save image as, then I'm gonna say four. Then again, I'm just gonna save. save image as, then 5, then save image as, then I'm gonna say 6. Then I'm gonna go to the image list. Then I'm going to say choose images. I want to show you guys something. So add images, then downloads. Then I'm gonna put them like that, open. Then notice that this now it's an array of images. So this is now an array of images. Now the names say they no longer correspond, but it's fine. Let me just move there. So move down, then move down, just for sorting purposes. Then move up, then move up. So notice that the image list, if we go to properties of the image list, if we go to image list, we have this images property. So this refers to this is an array, it's a collection, it's an array of images. Wait, what happened? Don't tell me I didn't add the images here. So I'm gonna say control, take this. Why does it? Okay. So I'm gonna add these images again. Then add image. Then I'm gonna say 1. Okay. So I'm gonna move this up. Then I'm gonna move this down. Then I'm gonna move this up. Then I'm gonna move this down. Then this up. So notice that let me say okay. Now if I go to images collection, I get this array. So you have position 0, position 1, position 2, position 3, position 4, position 5, like that. So let's say every time I click roll, I just want to display the first image. So I'm going to say in the picture box, I'm going to say the name of the picture box. Then how do I load an image? I say dot image is equals to, then how do we get a specific image in the list, in the picture box or in the image list? So I'm going to say image list. So this is image list dice dot images. Remember, images is a what? It's an array of what? Of images. So if I want the first one, I'm just going to say 0. So let's see how this works if I execute this. And before I execute this, let me just ensure that the size of the picture box and the size of the image list is the same, because if they are not, it's going to be weird. So I'm gonna copy this. I'm gonna go here, then change the size to this, like that. Now let me execute. So when I click roll, it's going to go to this roll and upload the first image. So if I click roll, oh, it was running. So if I click roll, so you see it uploaded the first image. Then if I click 1, it must upload the other image when I click on roll. So let's see. So if I say roll, it clicks, it uploaded the first image and so on. So what's the maximum position that you can access? If I go to the image list, Then I go to images. The maximum position that I can access is 5. You see, because 0, 1, 2, 3, 4, 5. So I am able to access the fifth or the last image with 5. So let's see if we can do it 5 and just execute this. And let's see how it works. So I'm gonna execute this. Then I'm going to click on roll. Then it did upload the last image. Then what happens if we click 6? So if we go to the image list again and view on the images we uploaded, look at the indexes. We have 0, 1, 2, 3, 4, 5. So 6 doesn't exist. So this won't work. Let's click on run again and let's click on roll. So it's gonna crash. So unhandled exception has occurred in your application. What? Invalid argument value 6 is not a valid index. So this is a logical error or it's a runtime error. It occurs when your code will successfully compile, but it will crash during like when you run your code. So that's the idea of uploading an image using a picture box. Then again, you can generate a random number between 1 and 6, maybe n equals to 0, for example. Then I say random. Actually, it's not necessary for me to initialize this. I can say int n, then I can say random n r equals to new random, like that. Then I can say random, n equals to r dot next. Then what must my arguments be? If I go to the images, I see that I can access 0 to 5. So the random number must be from 0 to 5 inclusively. So how can we do that? So I'm gonna say on this thing, I'm gonna say 0 to what? To 6, because 6 will not be included. Then I'm going to say at position n, like that. So that's how it works. Let's see. So every time we click roll, it's gonna generate a random number and upload a random image, like that. So it's just random. So that was the idea for the previous prac. Then, but adding the number to the list box, so we say lbo roles dot items dot add. Then we are going to say n. But remember, the die in reality must be 1, 2, 3, 4, 5, 6. But this number is between 0 and what? And 5. So to fix that, we are going to add 1 here. So I'm just going to put 1 here. Then if I click run, then I say roll. You see, it says 1. Let's go and see what's happening on our image list at position 1. So let's go to images. At position, it said what? 1, 1, 1, 1, 1. Let me see. Oh, it's that one. So so this means the generated random image was, index was 0. So we added 1, so which is a valid picture. So this is valid. If I say roll again, it's still 1. Now it says 6. 6, this means it generated 5. 5 plus 1, it's gonna be 6. So that was the idea of that practical. But the idea was to just understand that the image list is an array of images. We can access individual images. That's the way we do with arrays. So that was the main idea. It was not to explain the prac, but to explain the images, the application of arrays or real life applications application of arrays. So yeah, I think that's all for this video.